Have you ever wondered what actually happens when you click play on a Netflix show or send an email with Gmail? Where does your data go? What invisible machinery springs into action? Today, we're pulling back the curtain on the single most important technology of the 21st century, the cloud. The cloud isn't a fluffy white thing in the sky. It's a global network of massive data centers. To understand it, let's break it down into three parts. First, the front end. This is what you see and interact with. The Netflix app on your phone, the Gmail website in your browser. It's the user-friendly face of a very complex system. Behind that face is the back end, the powerhouse. Imagine warehouses the size of multiple football fields, packed with millions of powerful computers, storage drives, and networking gear. This is where the real work happens. It's managed by incredibly sophisticated software, a kind of brain for the cloud, that allocates resources and keeps everything running smoothly. Connecting these two, the front end and the back end, is the network. This isn't just your home internet. It's a superhighway of fiber optic cables, load balancers, and content delivery networks designed for blistering speed and reliability, ensuring data travels across continents in milliseconds. So how do these giant data centers serve billions of people at once? The magic trick is called abstraction, and it comes in two main flavors: virtualization and containerization. Virtualization is the foundation. It uses a special software called a hypervisor to slice up one powerful physical server into many smaller, independent virtual machines or VMs. Each VM acts like its own complete computer, with its own operating system and resources. This is incredibly efficient. Instead of one server running one application, you can have one server running dozens, each completely isolated and secure. Think of it like a single apartment building with many separate, secure apartments inside. Containerization is a newer, even more lightweight version. Instead of creating a whole virtual computer, a container just packages up an application and its essential dependencies. They all share the host computer's core operating system, making them incredibly fast to start and stop, and super portable. If VMs are apartments, containers are like individual, self-contained pods you can easily move around. Technologies like Docker and Kubernetes are the stars here, allowing companies to manage thousands of these containers at once. Cloud providers package these resources into different service models. You've probably seen the acronyms IaaS, PaaS, and SaaS. Let's quickly demystify them. IaaS, or Infrastructure as a Service, is like being a digital landlord. The provider gives you the raw building blocks: virtual servers, storage, networking, and you build whatever you want on top. It's maximum control and flexibility. Amazon EC2 and Google Compute Engine are classic examples. Next is PaaS, Platform as a Service. This is the developer's playground. The provider manages the underlying infrastructure and even the operating system and development tools. Developers can just focus on writing their code and deploying their applications without worrying about server maintenance. It's like renting a fully equipped workshop. Finally, there's SaaS, Software as a Service. This is what most of us use every day. Think Gmail, Salesforce, or Netflix. You just subscribe to and use the application through your web browser. The provider handles absolutely everything behind the scenes. It's ready-to-use software on demand. Companies can deploy these services in a public cloud, like AWS or Azure, a private cloud for just their own use, or a hybrid combination of both. But how are modern applications like Netflix or Uber actually built on this cloud infrastructure? The answer is a revolutionary design called microservices architecture. For decades, applications were built as monoliths, one giant, tightly coupled block of code. If you wanted to update one tiny feature, you had to redeploy the entire massive application. It was slow and risky. Microservices break that monolith into a collection of small, independent services. Each service handles one specific job, like user authentication, or the shopping cart, or video streaming. These services are developed and deployed independently by small teams. If the recommendation service on Netflix fails, it doesn't bring down your ability to search for a movie. This approach gives companies incredible scalability, agility, and resilience. It's why Netflix can update its platform hundreds of times a day without you ever noticing. Data is the lifeblood of the cloud, and storing it correctly is critical. Cloud providers offer different storage types. Object storage like Amazon S3 is for massive amounts of unstructured data. Think all of Netflix's movies or all of your photos in Google Photos. It's cheap and infinitely scalable. Block storage is like a high-performance hard drive for your virtual machines, perfect for databases that need fast access. And what about databases? The cloud has supercharged them. We have traditional SQL databases which are structured like spreadsheets, perfect for financial transactions. But we also have a universe of NoSQL databases, designed for the massive scale and unstructured data of modern apps. Think key-value stores, document databases, and graph databases that power social networks. This variety allows developers to pick the perfect database for the job, whether it's for a high-frequency trading platform or a global social media feed. But with all this data floating around in the cloud, how is it kept safe? Security is a shared responsibility. The provider, like Amazon or Google, is responsible for the security of the cloud, protecting the physical data centers and the core infrastructure. But you, the customer, are responsible for security in the cloud. This means configuring your virtual networks, managing who has access to your data, and encrypting sensitive information. The core principle is defense in depth, using multiple layers of security. This includes identity and access management, or IAM, to control exactly who can do what, strong network firewalls, and encrypting data both when it's stored and when it's moving across the network. The cloud is still evolving at a breathtaking pace. 3 trends are defining its future. First, serverless computing. This is the ultimate abstraction. You just write code as individual functions, and the cloud provider runs it for you. You don't manage any servers at all, and you only pay for the exact moment your code is running. It's incredibly efficient. Second, edge computing. Instead of sending all data to a centralized data center, edge computing brings the processing power closer to where the data is created, on a factory floor, in a smart car, or on your phone. This reduces latency and is essential for real-time applications like autonomous vehicles. Finally, AI and machine learning are being woven into the fabric of the cloud itself. AI is used to automate operations, optimize resource usage to save money, and detect security threats in real time. The cloud isn't just a place to run AI models, it's becoming an intelligent system in its own right. From the virtual machines that power our apps to the microservices that give them resilience and the serverless functions shaping the future, the architecture of the cloud is the invisible, ever-evolving backbone of our modern world. Understanding it is understanding the engine that drives our digital future.